Alright, this video is going to follow the videos on the algebraic definition of a circle. Just an example of how we can use it to find the equation of a circle given the center and the a point on that circle. So let's start with, I think I put it in the form of r is equal to the square root of x minus h squared plus y minus k squared. H and k being the center, the coordinates for the center of the circle, but since our center is at 0, 0, I can just put it in this form. R is equal to the square root of h squared plus y squared. I didn't need to be that long. Okay, so how do we find out what r is? Well, we can use the distance formula, and we can use these 2 points, the point on the circle and the center of the circle. So the distance formula is going to be the square root of the horizontal displacement plus the vertical displacement, or it's another way of seeing the Pythagorean theorem. So for here we have a horizontal displacement from the origin to this point of 1 and a vertical displacement of 4, so it's going to be the square root of 1 squared plus 4 squared, or the square root of 17. And then we can square both sides of this equation, and we have 17 is equal to x squared plus y squared. So this is going to be the equation of that circle with the point 1, 4 and the center 0, 0. Now we want to find an equation of the tangent to the circle at P. So one thing I haven't said yet, and I might go over when I go do more geometry videos based on the preceding theorems that we need, I'm definitely going to do that. But one of the pieces of information we need is that the tangent line to a circle is perpendicular to the radius for that point. So let me draw a picture first. So this is going to be the circle, the origin, and we have a point 1, 4 on the circle. So if I draw a radius to that point 1, 4, the tangent line is going to be perpendicular to that radius at that point. So this is talking about the slopes of these lines. Alright, well, first off, let's call this the slope of that line. Let's see. Well, I can write an equation for that line. I can say, well, y minus y naught. Actually, I don't need to say y naught. I have a point on the line already. It's 1, 4. So I can write the equation as y minus 4 is equal to m, let's call it mt for the tangent slope, and then x minus 1 times x minus 1. So this is the equation of this line, the tangent line. And I also know another piece of information. The slope of the tangent is equal to 1 divided by, since it's perpendicular, it's going to be 1 divided by the slope of that radius line. And we'll call that mr. So let's see if I can determine what mr is, and then I can substitute it into that equation. So the slope of that radius line, mr, is 4, since it moves 4 up for every one that it moves over. So that's going to be 4. I'm sorry, this is negative 1 over mr. So if we're finding the perpendicular, not only do we have to find the multiplicative inverse, but we have to find the negative of the multiplicative inverse. Gives us the, and that's maybe a piece of information I haven't said yet either. So I'm kind of taking for granted that we know that tangent lines are perpendicular to radius lines, and we know the relationship of perpendicular slopes. And the relationship is this. I could state that in probably a better way, but so what this tells me is that the slope of the tangent line is equal to -1/4. Now I can use this piece of information to find the equation for the tangent line. It's going to be y minus 4 is equal to -1/4 x minus 1. And then I can move the 4 to the other side and solve for y if I wanted to, but I'll just leave it in that form for now.